Hi everybody, Mike here again with another video, and the first thing I wanted to talk about today is adaptivity. Adaptivity is something you can give to features of parts to make them flexible. It's something that allows the properties of parts to be changed based on your needs. And the best way to show this is with an example. So here we have a simplified version of a tape measure, and basically what we want to make happen is the tape here to extend out of the base here. And we can do this with adaptivity. So as of now, this assembly is fully constrained, which means I can't move anything here. But this is not what we want. We want the tape measure to extend. So how do we do that? So let's say I remove this constraint here. That means I can move the end, but the tape doesn't come with it. But we need it to, and this is where adaptivity comes in. So I'll turn this back on. And so I can find the tape in the assembly browser and turn on adaptivity. And I can go to the tape part, find the extrusion, and make that adaptive also. So let's go back into our assembly and see what happens. So we'll enable this constraint as it's just an offset. So say I wanted the end to be 0.1 inches off the base. You can do that. Now say I wanted it to be 1/4 inch off the base. You can do that too. And say I wanted it to be 1 inch off the base, and it can do that too. So you can see how the length of the tape has been changed to fit the space in between using adaptivity. So let's see what happens when we drive this constraint. So go to our offset, go to drive, and let's say it has a minimum of 0.1 inches and a maximum of 360 inches or 30 feet. So I'll go down here and make sure drive adaptivity is enabled, and let's see what happens. Hit play here, and so you can see that the tape measure extends nicely, and we can't really tell the difference between this and real life. As a word of caution, don't use adaptivity on stuff you need drawings for. You can tell that if a part is sometimes one length and sometimes another, it can be kind of difficult to manufacture. Okay. So the next thing I wanted to talk about here was in-place components. And so these components are similar to parts, and they are constructed the same way. However, in-place components give you a greater reference to the existing assembly than parts do, and you'll see how in a little bit. Another word to the wise, don't use in-place components unless you really need to. They have a habit of backfiring on you and making your life difficult. So right here we have an assembly of rollers constrained to the same plane and a fixed distance apart from each other. So now say we wanted to make an O-ring and use it as a belt to drive the two together. Now previously this would only be possible by creating a new part, but a quicker way of doing it would be to create an in-place component in the assembly. And this is done by clicking the Create button up here. You can choose a file name and a path. And hit OK, and just click anywhere to start the construction. So now I have a plane here right in the middle of the rollers, and if I were to create a sketch on this, I can project geometry. I can project the centers of our rollers. I can create a slot. Say we could make that, 1.875 inches. Finish the sketch. Create a new sketch on this existing plane here. And just create, well, project this line first. Create a circle, 0.25 inches. Finish the sketch, and now we can make a sweep using this as the profile and this as the path. And now you see it has created our belt. We can click return here to go to the overall assembly. And you can notice that the belt is made adaptive by default. So basically what that means is I can change the distance here and it will adjust accordingly. So that's the basic idea of an in-place component. It's not something that is meant to replace parts. It just leans more toward linking parts in assembly together. And when you combine these concepts of in-place components and adaptivity, the possibilities are basically endless. Take a look at this assembly, for example. You've got an elastic band here wrapped around a cam, along with a winch to pull it back down. Let's drive this assembly and see what happens. And look at that motion. Really can't imagine what you would use this for, but there you go. And I think that about wraps up this video. So goodbye everybody, and I'll see you next time.